All right, guys, so we're going to figure out how to go from degrees to radians and radians back to degrees and doing everything in radians, okay? So what I showed you in class is that 360 degrees equals 2 pi and 180 degrees equals pi. So we prefer radians because it's more exact than a degree measure is. In order to convert between radians and degrees, you have to remember that 2 pi equals 360. So therefore, 1 degree equals pi over 180. So you take that pi and you divide it up 180 times and you get 1 degree. Likewise, 1 radian is equal to 180 over pi. All right, so if we're going to convert these over to radians, what we have to do is we have to multiply by pi over 180. So here I would end up with 45 pi over 180. If I can reduce, I must. And so 45 divided by 180 is actually 1/4. So this becomes pi over 4. You don't have to write the 1. Basically what you have to do is you have to treat pi like it's an x value. So if I had 45x over 180, I would put just the 45 over 180 in my calculator and I would reduce that. I would not put the x in the calculator. Same thing, you don't put pi in the calculator. You basically never put pi in the calculator because it's never going to pop back with a fraction for you. Okay? So then here we have negative 210. Same thing, I have to multiply by pi over 180. So I'll end up getting negative 210 pi over 180. That reduces down to negative 7 pi over 6. Okay, same thing here, 15, I have pi over 180. So this will give me 15 pi over 180. And that's going to end up getting me pi over 12. So 15 degrees and pi over 12 radians are equivalent. Negative 210 degrees and negative 7 pi over 6 radians are equivalent. 45 degrees and pi over 4 radians are equivalent. Now I can go back the other way. If I'm given radians, I can go to degrees. Instead, I multiply by 180 over pi. That's going to cancel these pi's out because pi divided by pi is what I'm going to have. Because if I multiply straight across, this is what I'm going to get. Where right here, I can just go right there, cancel those out. Then I have to reduce, and that's going to get me 90 degrees. Same thing here, I'm going to multiply by 180 over pi. That's going to end up getting me 360 pi over 3 pi. Cancel out the pi's, and I end up getting 120 degrees. And then this one right here is really weird, and you'll probably never see this again, anything like this. But I would multiply this by 180 over pi, and I'd get 700. I get 720 over pi degrees. It's really weird. You'd never probably see that again, but just in case, that's what you do. Okay, so pi over 2 radians is equivalent to 90 pi. 2 pi over 3 radians is equivalent to 120 degrees. 4 radians is equivalent to 720 over pi degrees. This one right here should make logical sense to you because if 180 degrees is equal to pi, half of 180 degrees is going to be pi over 2. It's half of pi. Okay? That should be a good, easy one to remember. All right. So now we have to figure out what quadrant each one of these is in. So easiest way to do this is to go ahead and multiply and get them into degrees, because we know really easily how to work with degrees. The only reason we would need to put these in degrees is if we can figure it out just using a little bit of common sense, or if they happen to be on our unit circle. So here I'd have 180 pi over 5 pi. The pi's would cancel out, and I'd have 180 over 5, which gets me 36 degrees. What quadrant is 36 degrees in? That's in my first quadrant. Here I have negative 4 pi over 7. Same thing. I'm going to multiply 180 over pi. And that's going to get me negative 720 pi over 7 pi. The pi's will cancel out, and now I have negative 720 divided by 7. Now negative 720 pi divided by 7 is going to get me negative 102.9 degrees. Now I have to remember this is negative. So I have to think negative degrees, if this is 0 right here, this is negative 90, this is negative 180, I'm going to be over here. So I'm in quadrant 3. Okay, 3 pi over 2. This is on our unit circle. We should know this one, but just in case we don't, we'll do it. It's 180 over pi. So now I'm going to have 3 times 180, which is 540 pi over 2 pi. The pi's cancel out, and that leaves me with 270 degrees. Now 270 degrees is on your axis. It's not in quadrant 3, it's not in quadrant 4. Here's 0, here's 90, here's 180, here's 270. 270 degrees. So it's actually right here on the axis. And I have to be specific. I have to say negative y-axis. I have to be specific and say negative, because if I just say y-axis, the y-axis could be either 90 degrees or 270 degrees. Likewise, if mine happened to land on pi, I would say negative x-axis, because it could be either 180 degrees or 360 degrees. I need to know which one. So I have to be specific on if it's on the axis, where it is, if it's positive or negative. Okay, right here, 11 pi over 8. Going to multiply by 180 over pi. And that's going to get me a really big number. 180 times 11 is 1,980 pi over 8 pi. I'm going to divide by 8, and I'll get 247.5 degrees. 247.5 degrees is in quadrant 3, because that's between 180 and 207. Okay. Now we're going to go to doing coterminal angles. I taught this differently in class, and I would rather teach it differently on here than I did in class. Okay, so coterminal. What coterminal means is that it ends in the same exact place as where I started, but it has a different degree measure. So in degrees, that means that I'm either going 360 degrees more or 360 degrees less, and I can do that an infinite amount of times. It's really important that we understand I can have an infinite number of answers for coterminal. Okay, really, it's like taking your degree measure and adding or subtracting 360 n times. Or, in this case, if it's in radians, I take my degree measure and I go plus or minus 2 pi n times. So however many times I need to. So this is telling me to find a positive and a negative. So I'm going to go ahead and add 2 pi. If I'm adding 2 pi, I need to remember that I need to have a common denominator when I'm adding and subtracting fractions. So in order to do that, I'm going to multiply both top and bottom by 5. And that'll get me 3 pi over 5 plus 10 pi over 5. Oops. So that's going to get me with an answer of 13 pi over 5. So that's a positive coterminal. Now I need to find a negative coterminal. So I'll take that same 3 pi over 5, and I'm going to subtract the 2 pi. So I do the same thing. I multiply by 5 to both. And now I have 3 pi over 5 minus 10 pi over 5, which that's going to get me 3 minus 10 is negative 7 pi over 5. So that's my negative. That's my positive. That's a really bad circle. There we go. Okay. I'm going to do the exact same thing right here. I have negative 2 pi over 3, so I'm going to add 2 pi. And since I've got to get a common denominator, I'm going to multiply both by 3. And so now I would have negative 2 pi over 3 plus 6 pi over 3, which that is going to get me 4 pi over 3. I'm going to do the same thing, and I'm going to subtract. Oops, let me do that in black. I'm going to subtract, so I've got negative 2 pi over 3. I'm going to subtract 2 pi over 1. If you haven't noticed, it's going to be the exact same number that I'm adding and subtracting once I find that common denominator. So negative 2 pi over 3 minus 6 pi over 3. And that's going to get me negative 8 pi over 3. So here's my positive, here's my negative coterminal. Those end in the exact same place as I started. Okay, that's all we're doing with this at this point in time. We'll talk about reference angles in a different video.